Hey everyone, welcome back to the channel Code Streak Daily. Today, now we are going to solve the daily lead code problem. Okay, now here we have a problem, make sum divisible by p. Now we have an array of positive integers named nums. Now we need to remove the smallest subarray, possibly sometimes empty, such that sum of the remaining elements is divisible by p. It's p is some integer. It is not allowed to remove the whole array. Okay, we have a condition specified. Now, next we are going to return the length of the smallest subarray that you need to remove or -1 if it's impossible. Okay, a subarray is defined as a contiguous block of elements in the array. Okay, this is the definition for the subarray. Let's dive into the example. Here we have an example num array and it consists of the elements 3, 1, 4 and 2 and the integer p equals 6. Okay, here they have the output 1. Let's see the explanation. The sum of the elements in nums is 10. Okay, 3 plus 4, 4 plus 4, 8, 8 plus 2, 10, which is not divisible by 6. We can remove the subarray 4 and the sum of the remaining elements will be 6. Okay, if we remove 4, then we will have 3 plus 1, 4, 4 plus 2, 6, which is divisible by 6. Okay, we have another example where the array consists of 6, 3, 5 and 2. Then we have the integer p equals 9. The output is 2. Okay. We cannot remove a single element to get a sub divisible by 9. The best way is to remove the subarray 5 and 2. Okay, these two elements. Then the remaining elements will be 6 and 3. Then the sum of 6 and 3 will be 9. Okay. Next we have another example where nums equals to 1, 2 and 3 and p equals to 3. Here the sum is 6. Okay, 1 plus 2 plus 3 equals 6, which is already divisible by 3. Therefore, we do not need to remove anything. Okay, now we have to break our code into some steps. So first we have a class defined solution and also a function min subarray where it consists of the parameters nums. It is an array and also p an integer and we have to return an integer. Okay, now we have to start by calculating the total sum of the array using I'm taking a variable called total underscore sum and I'm taking it as sum of nums. So total underscore sum will consist of the sum of all the elements of the array nums. And then we also take an variable called reminder where reminder is equals to total underscore sums modulo division done with p. So if this reminder is 0, it means the total sum is already divisible by p. So we simply return 0. Okay, if remainder is 0, then we are just going to return 0 because if the remainder is 0, that means the sum of all the elements inside the array are divisible by the given integer p. Therefore, we do not need to remove any elements from the main array nums or any sub array. Okay, therefore we can return 0. Okay, now next we have to set up a dictionary called I'm taking it as a prefix. I'm taking prefix map to store the last index of each remainder when we encounter, and we need to start with 0, map it to -1. Okay, so I'm taking it as prefix underscore mod underscore map. As it is a dictionary, I should use curly braces. I'm making it to 0 to -1. Okay, next we have to initialize another variable called cumulative sum to keep track of the sum as we iterate through the array, and another variable I need another variable called smallest length because we have to remove the smallest subarray possible uh, to store the length of the smallest subarray found initialized to length of the array. So for the cumulative sum I'm taking it equals to taking it equals to 0, whereas smallest length I'm making it as the length of the main array nums. Okay, now I have to iterate through the array. Now we loop through each element in the array. For each element we add its value to our cumulative sum and then we have to calculate its modulo p. Okay, for index and value in I'm taking the enumerate function in nums. Okay, so I'm just cumulative underscore sums adding the value to the cumulative sums. Then I'm taking a variable current underscore mod where I'm checking cumulative underscore sum modulo division with p. Okay, now we also have to calculate the target underscore mod where which represents what we need to remove to get the sum divisible by p. This is done by just adjusting our current modulo value with the initial remainder. So now we have to write target underscore mod inside the loop itself. Sorry, inside the loop target underscore mod equals here I'm taking it as current underscore mod minus reminder plus p and then making the modulo division with p. Now as we have done this, if this target underscore mod exists in our prefix map, uh, it means we found a valid subarray to remove. We will update our smallest length accordingly. Okay, so we need to write the condition if target underscore mod is in prefix underscore modulo underscore map, then what we have to do is smallest underscore length equals the we have to take the minimum value smallest underscore length as well as index minus prefix underscore mod underscore map of target underscore mod. Now we have to store the current mod value and its index in the map for future reference purpose. Okay, now we have to take that here. Okay, wait. We have to check that here. Sorry. Now prefix underscore mod underscore map of current underscore mod is equals to index. Okay, then we have to exit the loop and we have to return the smallest length if the smallest length is less than the length of number or the array. Okay, else we have to return -1. Now let me check if this runs good or not. Okay, total underscore sums is not defined. Okay, it's just sum. Run again. Cumulative underscore sum. Okay, there are minute errors here. Oh, target. I'm sorry, there are just typos. Maximum typos are there actually. Okay, our code is working good and the public test cases have been successfully submitted. Now let's see whether our code runs on the private test cases as well or not. Let me submit the code. Yeah, our code works perfectly fine here and we have a runtime of 402 milliseconds and it beats 47.59% of the users. Right. So this is how we have completed the coding and there we have it. We have successfully implemented the solution to this problem using the sliding window technique and also some modular arithmetic techniques. If you found this video very helpful, please give it a thumbs up, subscribe and let me know in the comments if you have any questions and don't forget to hit the bell icon to get the regular updates on solving the problem of the day for geeks and also the daily strict problems on the Leetcode. Keep sticking guys.